And here is the final 11th design pattern from the Gang of Four book. This pattern is called Visitor pattern, and it is a pattern you use when you want to perform operations on the elements of an object structure. I will start with a quick summary of what we are trying to accomplish with this pattern. The visitor pattern is a good choice when you are trying to accomplish the following. Many distinct and unrelated operations need to be performed on nodes in a complex data structure. You do not want to query the type of each node before performing the desired operation. Okay, let's go through the points one by one. So, the idea here is that you have some kind of data structure that consists of a large number of nodes of different types. You want to perform many distinct and unrelated operations on these nodes. You could do this with the iterator pattern. Use a for each statement to access the nodes sequentially. Check the type of each node and then perform the correct operation corresponding to the node type. But the key issue here is that you are unable, or maybe unwilling, to perform the type check. Perhaps because you want to avoid the extra performance overhead of a type check. So, how would you do this? The specific operation that needs to be performed on a node depends on two factors: the type of operation to be performed and the type of the node object. This is called a double dispatch in C#. The visitor pattern provides a solution for this scenario and implements double dispatch. Here's how the pattern works. The pattern uses a special class called a visitor that can perform an operation on a single node. The class has a visit method that receives the node as an argument and performs the required operation on the node. There is one visitor subclass for each desired operation. There is also a complex data structure consisting of one or more nodes. Each node is called an element, and it has a single method called accept that provides for the visitor. The accept method receives the visitor as an argument and calls its visit method with the this pointer as an argument. Now, this pattern uses two object-oriented tricks to implement double dispatch. When calling the accept method on an element, the .NET Framework calls the correct virtual accept method corresponding to the element type. This happens at runtime, and this is the first dispatch. The accept method then calls the visitor's visit method and provides the this pointer as an argument. The .NET Framework selects the correct polymorphic visit method based on the type of the this pointer. This happens at compile time, and it is the second dispatch. These two tricks implement double dispatch and ensure that the correct code runs for every unique combination of visitor and element type. The visitor pattern offers a number of benefits. First of all the code for the operations that we want to apply to the elements is in separate visitor classes. This keeps the public API of the elements clean. The elements only need to provide access to their value, and they do not have to implement each possible operation. This pattern offers a very elegant solution if, during the lifetime of the project, the number and type of operations can change. Every time when you add a new operation, you only need to create a new visitor class. You do not need to make any changes to the element classes. The pattern also implements double dispatch in an elegant way. By combining polymorphism and virtual method overloading, the pattern can run specific code for every unique combination of element and visitor type. Without the pattern, you would have to use a type check for the second dispatch, and this is less efficient. The pattern is not very well suited for the inverse of the above scenario. The number and type of elements can change during the lifetime of the project. Consider, for each new element type, you need to modify every single visitor class, because you need to add a polymorphic overload of the visit method. The pattern also presents a rather convoluted API, which is harder to maintain than simply using the iterator pattern, performing the type check, and accepting the minor performance overhead. Here is the UML diagram of the visitor pattern. I will start with the abstract visitor base class at the top of the diagram. This class declares an abstract visit method that must be implemented in a derived class. But look at the method declaration. The class declares one visit method for each type of element and relies on C#'s polymorphic method overloading to select the correct method. This is the second dispatch. There are two classes derived from visitor, called concreteVisitor1 and concreteVisitor2. The classes implement all polymorphic visit methods, and they differ in the type of operation they apply to the elements. You can add as many visitor subclasses as you like, one for each unique operation you want to apply to the elements. There's also an object structure containing one or more elements. The structure is represented in the diagram by the class objectStructure, and it refers to one or more element classes. There's an abstract element base class that declares a single abstract method called accept. This method accepts a single visitor as its argument. The method is implemented in one of the derived subclasses of element, called concreteElement and concreteElement. Both classes implement the accept method by simply calling the visitor's visit method and providing the this pointer as an argument. So here's how that works. To apply an operation to an element, you call the element's accept method and provide the corresponding visitor as an argument. Accept is a virtual method, so the .NET runtime will automatically select the correct implementation. This is the first dispatch, and it happens at runtime. The accept method will then call the visitor's visit method and provide the this pointer as an argument. Based on the type of the this pointer, the runtime will automatically select the correct polymorphic visit method. This is the second dispatch, and it happens at compile time. The visitor pattern is a very nice way to partition a collection based on the type of their elements. So I am going to use the pattern to do exactly that. I am going to partition a product catalog. Let's say I have a large e-commerce site up and running, something along the lines of Amazon. I have a huge product catalog with hundreds of thousands of products. My products are organized in a class hierarchy, with an abstract product base class at the top and product subclasses at the bottom. I want to quickly count the number of products in different groups, but without having to do a type check on each element. The visitor pattern is ideal for this task. I will implement the pattern with these classes. Let's take a look at the code. I will start with the visitor. You can see here that it is nothing more than an abstract base class that declares a number of abstract visit methods. For each concrete product, I have a single visit method that expects that product as an argument. I will rely on C#'s support for polymorphic methods to select the correct line of code. And here is the concrete visitor, called Product Partitioner. You can see that the class derives from visitor, and it sets up 4 integers to count the 4 types of products. Each visit method simply increments its corresponding counter. Okay, let's move on to the product classes. I will start with the abstract base class called product. All it does is declare an abstract method called accept that accepts a visitor as its argument. And here are the subclasses of product. The book class implements the accept method and simply calls the visitor's visit method with the this pointer as the first argument. And all other derived product classes do exactly the same. I'll conclude with the main program method. I start by setting up a small product catalog with a number of different products in it. Then I instantiate a product partitioner and use this loop here to call the accept method on each distinct product. Once the loop is finished, the partitioner will contain accurate counts for each product type. So these lines here write the product counts to the console. Let me run the program to prove that everything is working. I'm compiling the code now. And now I'm running the program. And there you go, accurate totals for each type of product. Everything works. Okay, so here is a quick checklist that you can use to implement the visitor pattern. First, verify that the number of concrete element types remains relatively stable. Then create a visitor base class with a visit method for each concrete element type. Add an accept method to each concrete element class. The implementation calls the visitor's visit method. Create a concrete visitor class for each operation to be performed on element objects. And finally, have the client create a visitor object and pass it to each element's accept method. And here are some final comments. The visitor pattern is often combined with the composite pattern to apply an operation to every node in a tree structure. The visitor pattern is more powerful than the command pattern. because a visitor can perform whatever action is appropriate for the type of element it encounters. In contrast, a command always performs the same operation. Okay, here is a recap of everything that we've learned in this lecture. The visitor pattern allows you to perform operations on the elements of an object structure. The pattern concentrates operations in visitor classes and does not need to perform dynamic type checks. The disadvantage of the pattern is that it is a lot of work to add a new element type. The pattern can be used to quickly partition a collection by type. The visitor pattern is more powerful than the command pattern, because it can perform different operations on each type of element.